Hey, everybody. Welcome to class. Before I begin, we have a guest here to speak to you real quick, one of my fellow faculty members, Kelly Bradshaw. So I'm going to let her talk to you all. Kelly, this is a small class. We have, I think, around 13 students enrolled, 14. So I think for the most part, I think you can probably start out if you'd like to, unless you want to wait for a few more.
No, that's fine. I can give you the information, and then if you do have any education majors that come in, just send them my direction.
Okay, very good.
Thank you so much for letting me come in. I appreciate it. As Professor DiGiovanni said, my name is Kelly Bradshaw. I'm one of the math faculty here at Northwest Vista, and I also work on our community math grant. And this is a grant that is designed for elementary education majors specifically, but education majors in general, to kind of help you get some resources as you're working through your degree and then getting started with that first job. Is there anyone here who is an elementary education major? Do I have anybody?
Yes, ma'am.
Awesome. Okay. So first thing I'm going to do is make sure your chat's open. I'm going to put my name or my address in the chat. So if you have any questions at all, you can reach me. We have several programs. I'm not going to spend a lot of time because I know not everyone's an education major, but I am going to put a couple of flyers into the chat. The first one talks about all the different activities that we do have, including several that you're eligible for right now, like our math enrichment, Spanish enrichment, and investigate your learning. Sorry, I've done this so many times and I'm getting tongue-tied. The second one is the dates for our committee of educator meetings. This next one is this coming Thursday evening at 6:30. I definitely recommend that you attend. It is on Zoom, and I am putting that Zoom link in the chat. And the last thing I'm going to put in the chat there for you is a link to a YouTube playlist where we have a short video. It's about 1 minute to 2 minutes for each video over all the programs that we have. So it gives you more information about everything. Now, being that you're in 13, 14, you won't be eligible for peer or parent tutoring until this class is finished, but you are eligible for the Spanish enrichment and the math enrichment. And everyone, regardless of major, can actually do the investigate your learning, where you actually talk about what it means when you learn something and how do we learn. But if you're an education major, you get a $100 stipend for it for completing. If you're not, we can't pay you, but you can still take the course. And if you're interested, just email me and let me know, okay? Who was it again that said they were in education major?
That was me, ma'am. I'm actually in your SDev class.
Oh, Raymond, I didn't even recognize you. So it's so funny when we're in different classes, you know, we just don't recognize the same people in these little bitty Zoom boxes. Thank you, Ray. Well, Raymond, you already know about all this, so you just let me know if you want to do anything. And if you find out that anybody else in this class is an elementary education major, would you send them my direction?
Yes, ma'am, we'll do.
Awesome. Thank you very much, Robert. I really appreciate you letting me take a few
Kelly.
minutes.
Take care. All right, bye-bye.
Bye.
Okay, thank you all for listening to that. There's all these opportunities out there for education majors to get assistance. So Kelly's visiting all the classes to make sure that she's getting to everybody. So, okay, without further delay, last week, obviously, we had some issues on Thursday with the campus closing down. I apologize ahead of time for not emailing the class. I got like 3 emails from the college, so I figured all of you got emails that said the class was canceled. So I should have sent something out. I apologize. So that means that we're a little bit behind, and that's okay. We'll catch up. There was no new assignment or anything like that, so we're just going to kind of pick up where we left off. Were there any questions over material from last time? Any of the homework problems I asked you to do, multiplying, adding, subtracting fractions? Everyone's okay? All right, at the beginning of classes is when I'm going to give the opportunity to answer any questions you might have, right? So please take advantage of that. If you're not able to make it to my office hours, you know, come in with a question if you have it. Today, what we're going to do is we're going to continue. Let's just look at the schedule because, again, we are a little bit behind. I'm not going to go redo the whole schedule. Last Thursday, we were supposed to get started with this stuff here, order of operations. And on Tuesday, when we met for the first time, we had only done the first part, fractions. We never did applications. So today, my goal is to cover applications, order of operations, and solving linear equations. If I can get through those three topics, at least I hope I can get to solving linear equations, then we'll still be behind, but we will slowly start to chip our way to get back on pace. Our first exam is scheduled for, is that a week from today? Is that correct? Week from today. That is right. So that means that on Thursday, I will be providing you a review, and then that review will help you. I'll provide the review, and then maybe a day or two later, I'll provide you the answers. And then when we come in, we'll take the test. Now, the test will not cover everything that's listed here because we aren't going to get through everything here. So the exam will only cover what the review says is on the exam. So you will not follow this. We'll talk about this more on Thursday once we know how much material we've gotten through. Is that clear? So the way I look at it, this first exam is going to be very minimal. It's going to have just very basic information on it. So I think it's a really good opportunity for you to do well because there's not going to be a ton of material. All right. Okay. Any questions? All right, here we go. So we're going to start off with applications. So we talked about on our first meeting, we talked about how you add, subtract, multiply, right? Fractions. We have these different methods that we discussed, right? And then at the very end, we talked about mixed numbers, proper, improper fractions and mixed numbers, and how to convert back and forth. So now let's do some word problems. And students usually struggle with the word problems, right? But what I'm going to do is I'm going to work through, I think, 6 word problems. And then when you go do your homework, hopefully it'll help you. All right. So here they are. These are coming straight out of the packet. Somebody sent out a message, I think it was in discussion board, asking about where are the answers to the homework problems. And I just want you to know that if you look at the packet, right, we have this packet, you have the electronic version of the packet. If you go to the very end of the packet, this is where you find the answers. So it says answer key here. I think it starts on page, I don't know, somewhere around 233. It'll show you like what section it's for. So like what page off the packet the answers are for. So if you just want the answers, it's not going to show the work, but at least it will show you if you got the right answer. All right. Okay, so here we go. We're going to do some word problems. And again, what I prefer to do is like give you these problems, let you work in groups and let you try and figure them out and talk through them. But because we're a little bit behind, what I'm going to do is I'm just going to work through them. And then hopefully when you go do your homework, you can use the video as a guide, you know, if you get stuck. All right, so Dolores sold candy by the pound. All right, the first person who came into her store bought 2 1/4 or 2 1/4 pounds of gumdrops. The second person who came in the store bought 5 3/4 pounds of jelly beans. So they're giving you some information about how much candy these 2 customers bought. The question is, how many pounds of candy did Dolores sell to her first 2 customers? So there's the question, right? Identify what we're trying to find. So that means we need to take the 2 customers, figure out how many pounds they each bought, and do what with that? Do what with those 2 numbers?
Add them together.
The operation. Sorry, Raymond, what did you say?
Add them together.
Add them together, right? We want to total them up. So we want to add them. So all I want to do here is take 2 1/4 pounds. I'm going to add to it 5 3/4 pounds. Okay, so this is very much like the homework, right? So the first thing I'm going to do is I'm going to convert both of these fractions or both of these mixed numbers into improper fractions. So that means I do that little, those little steps. I take the 2, multiply by 4, that gives me 8. I add 1, that gives me 9. So I put 9 over that denominator 4. That was the last thing we talked about when we met on Tuesday. How do you convert from a mixed to an improper? Then I'm going to add to that, and I do the same thing on the other fraction. 5 times 4, that's 20. I add the 3, I get 23. So I put 23, and then over this denominator, which is 4. And now I look to add these together. Since they have the same denominator, I can add them, right? So I'm lucky here that they have the same denominator. So all I'm going to do is take the 9 plus the 23, divide that by 4. This is going to be 32. Is that right? 32 divided by 4. And what is 32 divided by 4?
8.
Does it go in there? Yes. 8. What is it? 8 pounds? Or 8 should be the number 8. And then I'll put pounds because they're talking about how much candy, right? Now look, you may have been able to get to that answer without doing all that work. Maybe you just said to yourself, oh, okay, I have 5 pounds and 2 pounds, that's 7. And then 3/4 and 1/4, 3/4 and 1/4 together, that'd be 1 pound. So you put that together, you get 8. That's fine if you did it that way. That's fine. But the problem would come into play if those numbers weren't so easy to work with. Like maybe it was 2 and 1/5 pounds added to 5 and 3/4 pounds. Then it won't be as easy for you to add that up. So we have to have a method. This is the method right here. Am I making sense? You want to have a procedure for doing it. Questions on that one? All right, next one. In a language arts class, in language arts, the class was assigned to write a term paper or team paper. Each team was to write 5.5 pages for the combined paper. When all the teams put their papers together, there were a total of 44 pages. How many teams had worked on this paper? So what's the question? How many teams worked on the paper? So we want to know how many teams there were, right? How many teams? How are we going to get that from this information? Does someone want to tell me how they're going to do it? Like, what is the operation? You have 2 numbers that are given to you, 5, 5.5, and 44. Those are the 2 pieces of information. How are you going to put those numbers together in any way to get this answer?
44 divided by 5.5.
44 divided by 5.5. Let me write that down. 44 divided by 5.5. Okay, so this is where things get weird, to try and explain why that's the case. Like, why is it that we're doing division? So here's something that I recommend you do, all right? If you're ever having problems with the word problem, this is something you can try that might help you. Sometimes it's easier to make these numbers nicer numbers. So like, let's say this was 5 pages instead of 5.5. And let's say instead of 44, let's say it was like 40, all right? And now read through the problem, right? Each team had to write 5 pages. So imagine I put you into teams and each of the teams had to do 5 pages. And then when we put all the papers together, we had 40 pages, right? 5 pages from each team, 40 pages total. The way you get how many teams you have is take that 40 and divide it by the 5. All right. Now, I'm not saying that's a guaranteed way to work all the time. It's just sometimes people get caught up on the numbers instead of thinking about what the actual operation is. And if you make the numbers nicer, sometimes it makes you figuring out what the operation is easier. So if this was 5 and 40, you would do 40 divided by 5, right? Or 40 divided by 5. That's what you would do. So that's not what we have here. Unfortunately, we have the 5.5 and the 44. So we are going to do exactly what I think it was Cambry said. We are going to take the 44 and divide it by 5.5. So we're back to the homework again. 44 divided by 11 over 2. So first thing I did is converted the 5.5 over to an improper fraction, right? 5 times 2 plus 1 is 11 divided by 2. Then I'm going to rewrite 44 as a fraction, 44 over 1 divided by 11 over 2. And what's this next step? How do you do division of fractions? See, I've heard from Cambry today. I'm going to mark you down, Cambry, as responding. And Raymond, I think you've responded, haven't you? How about Corwin?
Yes, sir.
Corwin, you here?
Yes.
Okay,
You
so
flip
what would you do
the-
here, Corwin?
You flip the 11 over 2?
You flip the 11 over 2 and make it 2 over 11.
Yes.
And then what about the operation between the two?
You multiply.
You multiply. So that was that thing that we talked about, keep dot flip. That's exactly what we're doing here. We're converting the division to multiplication. And then we can go straight across, right? So Corwin, when we multiply straight across, I'm just asking you, Corwin, how you would do this. Would you just do 44 times 2 and then 1 times 11? Or would you actually try and simplify this first? What would you do, Corwin?
I would simplify the 44 and 11.
Okay, so you see that this reduces, right? 11 goes into 11 once, and 11 goes into 44 4 times. Now you have to see that, right? Corwin sees that. If you don't, you're gonna have to go all the way across and then try and reduce that answer. Okay, good. I like that. Thank you, Corwin. So what are we gonna get here? 8 over 1,
Yes.
which is 8. And that's correct, 8. Now, my answer needs to have something attached to it. I can't, 8 is correct numerically, but the question was how many teams, right? So I should put here 8 teams as my answer. Okay, so the first question had to do with adding 2 fractions together. The second question had to do with dividing 2 fractions. Let's see what the third one has to do with. Dennis's new dog weighs 127 and 3/4 pounds. His friend's dog weighs 94.5 pounds. Those are big dogs. How much more does Dennis's dog weigh than his friends? All right, so how about somebody volunteer who has not talked today? Go ahead, Brandon. What do you got? How would you do this?
I'm going to be subtracting.
Okay, subtraction. Good. Now, Brandon, let me ask you something. When you subtract something, does the order that you do it matter? Like anytime you do subtraction, does it matter how you order them? Will you get different answers if you change the order?
Yeah, but in this question, you'd have to do the bigger one first.
So you're going to take the bigger one and subtract the smaller one. Yes?
Yes.
Okay, good. Yeah. So it does matter, just as an ancillary thing on the side here. Whenever we do subtraction, order matters. Addition doesn't matter. When you add 2 things, the order is irrelevant. But when you subtract, the order is important. So when we do this, like Brandon said, we're going to do the larger one and we're going to subtract the smaller one, 94 and 1/2, like that. Okay, good. Brandon, let me mark you down here. Let's see, where are you, Brandon?
My name's actually Garrett. It's for some reason put my dad's name on the thing.
Okay, so your Zoom is wrong, but on the roster is correct.
Yes.
Okay, very good. All right, so now we're doing the subtraction. Now look, I realize that some of you have done this stuff before, maybe in high school or before that, whenever you did this. And there are so many different ways that you could do this. Some of you, I know my daughter has done something like this before, where she's taught how to, like, you line things up like this. Have y'all seen that? You do it and you do it like vertically. Y'all seen that when you subtract something like that? If you haven't, it's okay. If that's the way you learned it, great, but you need to make sure you get it right, because that's very dangerous to do it this way. I'm not going to do it that way. I'm going to stick to what I've been doing before, which is I'm going to convert all my mixed numbers to improper fractions, work with the improper fractions, and then go back to a mixed number if I need to. All right, it's just safer to do it that way. Trust me on that. Okay, so here we go. The numbers are going to get big. I'm going to need my calculator. And let me go here. So I'm going to take the 127 multiplied by 4 and then add 3. I get 511 over 4 minus, now I do 94 times 2, add 1, I get 189 over 2. Any questions on that? I'm converting those mixed numbers to improper fractions. We're good. Now we need a common denominator, and notice that these denominators are not the same, right? So this is where I gave you 2 options. You can get the common denominator, or you could do that little quick cross thing, the shortcut. But I warned you that if you do the shortcut, your numbers can get big, right? So what would y'all prefer we do here? You want to do the shortcut or you want to do the other way where you just kind of like get the common denominator? What do y'all think? Shortcut, thumbs up or down for shortcut, the cross thing. Thumbs up or no? No, y'all want to do the other way? Okay. All right, so I'm gonna do the other way. The other way is to look at the denominators and get the LCD, which would be 4 here, right? So I got to turn both denominators into 4s, which means I'm going to multiply this fraction by 2/2. That's the only thing I have to do. So I'm going to rewrite this as, let's see, 189 times 2. What is 189 times 2? You'll have your calculators. I need to get my good calculator.
378.
378. I don't know where my good one is. 378. Okay. Now you have the same denominator, so you can put 4 here. And now just do your subtraction, right? 511 minus 378, 133. All right, so that's our answer. And if you were to box this up, that would be correct. The problem with it though is that it's an improper fraction. It's not a mixed number. So it's not really given to us in the same format that the original numbers or the original weights of the dogs were. So it might be useful for us to convert this back to a mixed number. And if you look at the end of the packet where it has the answers, it would have it as a mixed number. It would not have this answer. But on a test, I would take this as an answer because it is correct. So I'm going to go back to a mixed number. And to do a mixed number, here's what I have to do. The good old-fashioned division. So 4 goes into 13, 3 times? And that gives me a 12 here. I subtract, I get 13. And then 3 again. And that gives me another 12. And then I have a remainder of 1 here. And it gives me 1/4. So we should get 33 1/4. Okay. I realized that took a lot of time. And I know that some of you are very like kind of wishing we would have done it this way. But like I said, this is dangerous. So if you're going to stick to this way, I hope you really know how to use it, because if I change this 3/4 right here to a 1/2 and that to the 3/4 instead, this way becomes very dangerous, right? You can get it wrong very easily. So this is the way that I prefer, but you choose. Everyone's coming in here with a different background, so it's hard for, I'm not going to force you to relearn something as long as you know how to do it correctly. Questions on that? All right, we move on. Let's see here. All right, I'm going to let you read through the first one. Why don't you read through the first one on your own, and then I'll take a volunteer, someone who has not spoken today, to tell me what they would do on this one. If no one volunteers, I'm going to call on someone. But I'll give you a minute to look at it. Okay, I'm gonna try this a little different here. I'm going to. About to launch a poll. Just give me a second. I've gotta fix the poll real quick. Wasn't quite ready to go. If you've got it, read the next question. Okay, I sent out a poll here for this one. We have choices A, B, C, or D here. Which is the correct operation that we need to do with those numbers for this problem? We've got 7 people have responded, so 8, 9. Okay, we got 11, 12. There we go. I think that's everyone. Okay, everyone got that right. So correct answer is B. Good. We are going to subtract. Now, I'm not going to do this. I'm going to let you do this. All right. Not right now, but this is like a homework problem at this point, right? So you should be able to do that subtraction. The numbers are going to get a little ugly because they're big, but I'm going to let you do that. Let's look at the next one and let's do the same sort of thing. Let's see if you can come up with what operation we do for this one. So I'm going to relaunch the poll. Let me give you the answers. Relaunch poll. Okay. Don't give me an answer yet because I haven't given you any choices. But here, are we going to do division of these two? What are we going to do? Hold on. Let's talk through this one. And I don't think it's going to be easy for me to give you 4 easy choices here. Jerry bought 12.5 pounds of candy to share with his friends. If he gave 2.5 pounds each to 3 friends, how much candy does he have left over? So somebody help us out here. Somebody who hasn't talked today.
Wouldn't you multiply 2.5 by 3 and then subtract that from 12.5?
You're gonna do, okay, so let me write that down. You said, wouldn't we multiply 2.5 times 3, figure out what that is, right? That's gonna be something, right? And then he said, take that answer and do what with it?
Subtract it by 12.5.
Subtract it from 12.5. Yes, that's exactly right. So we're going to figure out if he gave 2.5 pounds to each of his 3 friends, that would give us how much money, how much candy he gave away. And then when we subtract that answer from 12.5, that'll give us how much he had left over. Very good. So let's do that. Any questions on that, what we're doing? I'm going to rewrite this. I'm going to turn this mixed number into an improper fraction. It's going to be 5/2, 5 halves, times, now the 3 I'm going to rewrite as a fraction, 3/1. Let's see, who just spoke? Keely, is it Keely? Is that right?
Kylie.
Kylie, okay. All right, got you, Kylie. Kylie C, last name?
No, it's Della O.
I'm looking for you on my roster. I don't see you.
It's Kielee, not Kylie.
Yeah, but you're not on my roster at all. Did you come into the class late or no? Like, did you add late into the class?
No,
Last name starts with what letter?
a D.
The D?
Yes.
Yeah, you're not on here. I'm gonna have to check.
Okay.
You are showing up when you log in to Canvas and stuff, you're on there?
Yes, I am.
I'm gonna just check real quick. I hope everyone doesn't mind. Let me just check to make sure. Okay, you're there on my roster. I guess for some reason you're not on this. I'll put you in. Were you here the first day?
Yes, it was.
Okay. All right, there we go. I've added you to that. Okay, so we're multiplying straight across right here. So we get 15 over 2. And we're going to take that answer and subtract it from 12 and a half. So now the next step here would be to take the 12 and a half and subtract the 15 over 2. I would turn this into an improper fraction first. So that would be, let's see, Allison, are you there?
Yes.
Allison, can you tell me what this is converted to an improper fraction?
23 over, oh wait, yeah. 23 over
Careful.
2.
Where are you getting 23? Oh, did you already get the whole answer? Or
Oh,
I'm saying just this piece
oh
right
no,
here.
sorry. Isn't it 12 over 1/2?
12.
Oh wait,
I'm talking about where you take the 12, you multiply times 5, right? And then you add the 1.
yeah, I'm just confused on where you got the 1/5.
Oh, yeah, that's a very good question. Because I wrote it down wrong. That's why. Okay, there you go. Now, sorry, you said 20, you said 23 or 25, I forgot.
23 over 2.
Okay, so you are correct that I had it written down wrong. I apologize. But 12 times 2, that gives you 24, right?
24, yes, 25.
And then
I'm
you
sorry.
add 1, so 25 over 2. So, okay, sorry about that. I'm probably confusing you by making a mistake there. There we go. We all good now? Okay. And then now we just subtract the tops, right? So when we subtract the tops, we get 25, take away 15, that's 10. Over the common denominator 2, that should be 5. 5 what? Five what here? So how much candy does he have left over, right? Is what we're looking at. So that should be measured in the units here, pounds. Okay, let's do one more and then we're gonna move on. All right, so I'm letting you read the problem. Let me give you the options here, what to do, because this one is just an operation on those two numbers. So let me give you the choices, then we'll do a poll. All right, there we go. Relaunch the poll here. Which of those is the correct operation to solve this problem?
You have division on there twice.
I do, but they're in different order.
Okay.
Okay, I've got 8 responses so far. Waiting on a few more. I like doing this poll because it gives me a real idea of like, is everybody okay with this or not, you know? Okay. All right, I think that's good. I think we're still waiting on one more, but this is good. All right, so almost all of you selected the correct answer, which is to take the total time it took them, 23 and 2/5 minutes, and divide it by the time it took to run one lap, which is 4.5 minutes. So you would convert that over to improper fractions, and then you do the keep dot flip, okay, which I'm not going to show. So good. Now, if you didn't get that, if you chose something else, you know, wait after class and we can just talk through this and I can explain why it's not this one. Okay, because some of y'all picked this one. Okay, that's it for word problems. I'm gonna, you know, for you, what you're gonna need to do now is go to the packet and let me see what page this was. So I'm trying to get to the homework. Yeah, it's 225. Oh, there it is. Okay, so here was the homework from last time, right? It was on page 221. And we stopped about here. Now what I'd like for you to do is page 222. Just try all of these problems here. 222. So for the homework, do page 222. Just do the odds on there. And of course, if you want more practice, do the evens. But at least with the odds, you'll have the answers. And then if you have something from the, you know, that you want to talk about beginning of next class, I can go through one of them if you need me to. Any questions? All right, we're moving on. Order of operations is our next topic. So order of operations, I'm sure you've heard of before in the past. It's basically, order of operations is the agreed upon order in which we compute mathematical expressions. So as human beings, as we were developing math, we had to come to an agreement as to how we would do things, like what we would do first. If we ever saw like multiple operations occurring in one expression, we have to say, oh, let's just all agree to do it this way, okay? We didn't have to do it this way, but we have an agreed upon way. So I have a question here for you to look at. I want you to take 12 divided by 4 times 3, right? And I want you to tell me what the answer is. I'm gonna launch another poll. I have the actual thing ready for you here. Where was it? Order of operations. I want you to choose which answer you think is correct. I'm gonna give everybody a minute to do that. We're almost there. Okay, we've got everybody responded. Oh, very interesting. Very interesting results. I'm sharing the results with you there. We're almost 50-50 here, thinking that the answer is 1 and 9. All right, so let's talk about the answer of 1. Okay, so how did the students who got 1, how did they do that? Well, there's really only one way it could have happened. They did the 4 times 3 first, right? And they got 12. So it became 12 divided by 12. And of course, 12 divided by 12 would be 1. So I understand how those students did that, okay? And then the students who got 9, what they did is they do 12 divided by 4 first, which gives you 3, and then they did 3 times 3, and then that gives you 9. Okay. So this is why we have to have an order of operations, so that this doesn't happen. We should, whenever we're doing math, we should all get the same answer. It shouldn't be like ambiguous where, oh, well, I did it this way, so here's my answer. And you're like, well, I did it this way, and here's mine. You can't build bridges or, put people on the moon, or, you can't do things like that if we have different answers. So we have to agree upon the order of operations. Now, the one on the left where the student got 1, here's, I believe, what they did, and you correct me if I'm wrong. They went off of this thing that's taught in school, PEMDAS. Am I wrong? The people who got 1, is that what y'all did? You use PEMDAS? PEMDAS is this little thing that we use to help us remember order of operations, where, this says, oh, you do what's in parentheses, then you do you do exponents, then you do multiplication, then you do division, you add, and then you subtract, right? That's basically what it stands for. Okay. And so when they did this, they said, all right, do parentheses first. Okay, there are no parentheses. Do exponents. There are no exponents. Do multiplication. All right, do 4 times 3. Got it. Now do your division. There's your division. You get 1. So I see how they did that. How about the 9? I had 6 people get 9. So can someone who got 9 tell me what they did, like why they did this? Who got 9? I know 6 of you got 9.
I can say, I guess. Great. Multiplication and division go at the same time, so you go whichever order it goes in first. So division was first, so you do division first.
So you agree with PEMDAS to an extent. You're saying that the way you were taught PEMDAS was not that multiplication comes before division. You were taught that they're kind of like equal.
Yeah, same thing
And
with
you just-
adding and subtracting.
And adding and subtracting, they're equal. And you just go like from left to right, the way you'd read a book. Like almost like which appears first. So you did the division because the way you were taught, look, when you see multiplication, division, multiplication is not better than division. You don't do multiplication first. You just read it like a book, left to right. Am I saying that the right way? Kind of the way you understand it, the way you were taught? Okay. That is the correct way to do it. All right, that is correct. So if you were doing this, I'm not going to say you were taught wrong. I'm just going to say that maybe it wasn't emphasized enough that multiplication, division, and addition, subtraction are equal operations. Multiplication does not go before division. Division doesn't go before multiplication. They're equal, and you will do them in the order that they appear as you move from left to right. Now, I can remember being a student and getting this problem wrong. As a student, I remember getting it wrong and being mad because I was like, well, wait, that's not what I was taught. I was taught PEMDAS. Wow, I was all pissed off. So I'm not trying to piss you off. I'm just trying to make sure you understand the rule the correct way. This is wrong. This is right. All right. So the answer is 9. That's why order of operations is so important. We need to all get the same answer, right? So we will follow PEMDAS, just we'll follow it this way, right? This way, not this way. All right, let's do some more complicated problems. That was a very basic problem. We're going to now move on to more difficult ones. So I'm going to copy this over and we're just going to start cranking these out. All right, let's start with the very first one. The instructions are to simplify the expressions. That means I need to like remove all the parentheses. I need to make this turn into a nice final answer. So when I look at this problem, I'm going to first see, if I'm following PEMDAS, where those two are the same and these two are the same. The first thing that I see is this 10 minus 2 in a parentheses, right? I also see a 72 in front, and it's important to understand that that 72, that there is a multiplication symbol right next to it, even though we don't normally write it, it's there, all right? So I have 5, take away 3, add 72, multiply 10 minus 2, but you have to do the 10 minus 2 first. What I recommend, okay, when you're doing these problems, I recommend that you don't try and do it all in your head. I mean, if you can, great, and you get the right answer, great, but don't be afraid to like write math down line by line. So I would recommend you do something like this. Say that this is equal to, and then rewrite right below it everything. Except for this step here, change that 10 minus 2 to an 8. And notice I put the dot there for the multiplication, and that's to help me remember that my next operation is this multiplication, because I have subtraction, addition, and multiplication left. I've got to do that multiplication first. So somebody who's got a calculator, let me try and get through everyone here. How about the other Kylie? I've got 2 Kylies. So Kylie C, how about you? You got your calculator handy? Uh-oh. All right. How about Jose? I don't see Jose here. I don't think Jose was here the other day too. All right, Alexis. Okay, Kylie's microphone's not working. That's good. Thank you for letting me know. So no Alexis. I'm really just doing this for attendance. How about Keegan? Keegan, you got a calculator handy?
I do.
I don't know if you need it, but if you give me 72 times 8.
576.
576. Okay, so now Keegan, what would I do next? I did the multiplication, or what would you do next with this right here?
You'd add the 5. Well, you subtract the 5 minus 3.
You do 5 minus 3, that would give you what, 2?
Yep.
And then you add that to 576, and you should just get 578. Trying to squeeze it in here. That all good?
Looks like it.
Okay. All right, now look at the next one. Number 2, we've got a lot of stuff going on here. We have a set of parentheses here, right? This is a dot right there after the 2. Here, we've got this set of parentheses. We got to do what's in there. We've got these powers, we call those exponents. Then we have another set of parentheses and another power. So this is where it's really good to just take your time through this, just write line by line what's going on here. So I think what I'm going to do is, oh, you know what, I'm going to copy this and put it below so I have a little bit more room to work with it. All right, so again, this is what I would do. I would say equals, and then I just rewrite everything, 2 plus 2 times. Now I can do what's in here next, right? I can do this. So Abigail, you here? Abigail? I think I heard you. There you go. How's it going? How do you feel about 3 minus 6?
What do you mean?
I'm doing this. Do you feel comfortable with doing subtraction of integers like this?
No.
No?
No.
Okay, so think about it like money. If you had $3 and you take away 6, are you going to have money or are you going to owe someone money?
I'm gonna owe somebody money.
How much?
like $3.
$3, right? So that's a -3, right? When you do the subtraction.
Okay.
So don't overthink it, right? I always think treating it like money makes it easier, for a lot of people. You have $3, you take away 6, that means you're in the whole $3. So I'm going to put here -3. Now it's very important that I have this multiplication symbol here because I need to realize I'm going to multiply these two numbers together. It might also be helpful if you just put it in parentheses. So the thing is, you need to realize that that's not 2 minus 3. It's 2 times -3. Those are two different things. Are we all clear on that? I'm going to keep moving across here. I'm going to put equals, and I'm going to keep writing things down here. Parenthesis, 1 plus, and now I'm going to do what's in red. And let's say, Abigail, let's do it again. Abigail, what about 1 minus 4? Think about money again.
Same thing, 3.
Same thing, -3, right? -3. Now I'm going to put that -3 in parentheses because I still need to square it. So I'll do that. I'm going to do that on the next step. I'm not going to do it right now. And then square. Okay, so this line is equal to this line. And now I continue. Equals 2. What should we do? Let's just leave all this alone for now. I'll come back. I'll finish this up in a minute. Let's do this right here. 1 plus, okay. What about, is it Jareth? Jareth, am I saying that right?
Yes, sir.
Yes, Jareth. How about that? How about this right here? What is this?
Would it be 9?
Would it be 9? It's -3 times -3, right? That's what it means?
Yes, sir.
And a negative
Yes.
times a negative should be positive.
sir.
So yes, +9. Good. So that's +9. And then that's all of that squared. And then we keep moving. All right, we keep doing this. I realize this is tedious, right? But I think I'll do one more before I put those together. Okay, I'm gonna do what's in here now. That's 10, right? 1 plus 9 is 10. So we have 10, and then we still have to square that. So 2, now I think I'm ready to do this. I'm ready to do that operation. I could wait and do it on the next line, but I think I'll do it right now. So Sarah, what do you got there?
Do you want the answer or do you want?
Well, the multiplication of these two, that's all.
Oh, -6.
-6, you're comfortable with that?
Yes.
Okay, so we're gonna say plus -6, right? Which is weird notation. We don't usually like to write it that way. We would prefer to have a parenthesis around it so that you look at it as 2 plus -6. And then we'll have minus, and then Sarah, let's just finish this off. You're gonna do 10 squared, right?
Yes, 100.
So we just do 10 squared is what?
100.
100. Okay. We're getting there. The operations I have now are addition and subtraction. So I'm just going to move from left to right. Ashley, you're up. Do the first two.
2 plus -6 would be -4.
-4. So Abigail, again, think about it like money. Right? I say Abigail because I know Abigail's not the only one that would maybe have trouble with this. This is like you have $2 and you're going to add to that money you owe to somebody, right? So it's like, oh, I have $2 and I'm adding a negative amount. So I should have a negative amount of money left. So this should be, as Ashley said, -4, then minus 100. Ashley, you want to finish that off?
And then it would be 100 or -104.
-104. And again, think about it like money. -4 means you owe somebody $4 and then you're going to take another 100 away, right? You take another 100 away from a negative already, you're going to have more negative. So -104. That's our answer. So the thing about these order of operation problems is that there's a lot of room for error, right? Like if you just make one little mistake, it's all wrong. So you want to make sure that on the test next week that you're showing me the detail. Because if you just give me an answer and it's wrong, I'm going to give you no points. All right. But if you show me all the detail, and then I can tell, like maybe you put like +6 right there. If I see that little mistake, I won't take off 10 points. I'll just take off maybe a point or two, but you have to show me the work, okay? I have to see that you've gotten everything else right. Okay, let's try another one. I'm gonna let y'all pick. Well, let's just do 3. We'll do 3 because it's a little different, and we'll do 4. Go to a new page for this. So we have this symbol here. This symbol right there, that's called our square root symbol. And everyone here needs to know what it means, right? So if you do like the square root of 4, the answer is 2, right? Because it's saying what number times itself gives you 4. The square root of 9 would be 3, because 3 times 3 gives you 9. Square root of what, 6? What would be the next perfect square? 16. So 4. Square root of 16 is 4. What's the next perfect square after 16? Square root of what?
25.
25, right? Would be 5. The next one would be square root of 36. So you need to recognize what the square root means, all right? Now, this is asking us to do the square root of 5 squared minus 3 squared. So what I'm going to do first is I'm going to actually square the 5 and become 25. And then subtract from that the 3 squared, which is 9. Then I'm going to take 9 away from 25. If I do 25, take away 9, I'm left with 16. And the square root of 16, like we just said, is 4. So the answer here is 4. Here's a mistake, all right? I don't like to write mistakes, but this is a mistake. This is not equal to the square root of 25 minus the square root of 9. In other words, you cannot take this square root and do the square root of each one individually. See, that's what I'm doing here. I'm saying, oh, let me take square root of that one and then subtract the square root of that one. That is not correct. That is not the way you do it. You have to figure out everything here together, and then you can take the square root. All right, so that is no go. Questions? Number 4. Do y'all know what these bars mean? These vertical bars, what they stand for, there's a name for it. Absolute value. I've heard that before, absolute value. So you need to know what that operation is. So if you write the absolute value of any number, like 5, the answer is the number itself. If you put absolute value of -5, the answer is also 5. Think about the absolute value as this thing that what it does is it takes whatever number's inside of it and it always gives you the positive answer. So it turns positives. If you have a positive in there, it leaves it positive. It has a negative, it changes it to positive. And then what would the absolute value of 0 be? What do y'all think? Is 0 positive or negative? Or neither? What do y'all think? Turns out 0 is not positive or negative, all right? 0 is the only number that's not positive or negative. So when you take the absolute value of 0, it just spits out 0 itself. So when I look at this problem, what I'm going to do first is I'm going to figure out what 4 minus 8 is. Abigail, will you get mad at me if I pick on you again?
No.
Okay, because I want you to understand, I don't want you to be afraid of these numbers like 4 minus 8. I don't want you to be, you know, math is like that. Like when you're uncertain about something, math becomes very difficult. Okay, but once you build a little confidence in it, it gets a little better. So what about it, Abigail? 4 take away 8?
It's -4, but you said it turns it into a positive, so then it's just.
Yeah, absolutely. I'm going to put +4. I just want to do, I'm going to say that for the next step. So this is going to be -4 in here, and then the absolute value, I'll do it on the next step. Then we have -9 times, and then let's go ahead and do the inside of this. 2 take away 3 is -1. So I'm going to put -1 in parentheses like that. I'm going to multiply these two together now. And I'm also going to take the absolute value like Abigail said. -4, take the absolute value, you get 4. Take away 9 times -1. 9 times -1 should give me a negative number, right? -9. But we're subtracting it. So what you want to do is make sure you have that in parentheses so that when you subtract a negative, what happens when you subtract a negative? Anytime you try to subtract a negative, it becomes what? Addition. Or plus. And so 4 plus 9 is 13. Questions there? I think it's time for you to work through one or two of these. How about this? How about you try 5 and 6 on your own right now? And then what I'll do is I'll put up a poll and we'll see if y'all get the right answer. I'll give y'all some choices, all right, for the correct answers on these. So work these out on your own. If you happen to get a fraction as an answer, just leave it as a fraction. Don't go to your calculator, just leave it as a fraction. Okay, I put a poll up for the first question. I think we're going to talk about the second question. If you're having trouble on the second question, do that first. Okay, add those two fractions first. And then I think this will be a good way of doing this. In the chat, if you have the answer for 6 as a fraction, send me a chat with your answer. You'll only be able to send it to me, so I'll be able to see. You all understand what I'm asking? If you get the answer for the second one, send it to me in the chat. I'm going to give you all a few more minutes because this will be the last thing we're doing today. All right. Sarah, you don't have to ask if you need to go. You got to go, you go.
Okay, thank you.
Yep. All right, so I'm getting a lot of, I've only got a couple of answers here. So let's work through it. We only have 5 minutes left. So let me work through it, okay? I got 131 over 120. That's what I got. So I do see a couple of people did get that. So this is a tricky problem. Let's make sure we're all good with it. So the first thing that I would do is add those two fractions together. And there you have options, right? How you do that. If I were doing it, I would do the short way where I do like the cross thing. I would just go 2 times 3, that's 6. I would add to that 5 times 1, that's 5. And then 5 times 3 is 15. And that gives me 11 over 15. Okay, so that's what that top right corner is right here, 11 over 15. So let me rewrite the problem. I have 1 plus 11 over 15 over, now 2 to the 3rd power means 2 times 2 times 2. Right? That would be 8. So I'm going to go ahead and put that here, 8. All right. Most of y'all get to that point? Okay. You feel okay with that? No? Okay, now what I'm going to do is I'm going to take this 8, I'm going to rewrite the 8 as a fraction and realize that what this is really saying is 11 over 15 divided by 8 over 1. See, that's what this means, right? And then I can turn this division into the keep dot flip, where I flip that over and then multiply straight across. So this will give me 11 over, I think that's where I get the 120 from. So 11 times 1 is 11, 15 times 8 is 120. So that means that this becomes 1 plus 11 over 120. Does that make sense, everyone? Any questions there? Last step, add these two together. I have to look at them as fractions. So I'm going to rewrite the 1 as 1 over 1. And then again, you have options here. You can do the cross thing, or you can get a common denominator. Your choice. I'm going to do the cross thing again. Multiply 1 times 120, that's 120. Plus multiply 1 times 11, that's 11. And then on the bottom, I multiply 1 times 120, that's 120. And then when you add across the top, you get 131, and on the bottom, you get 120. And that is the fractional answer. So for those of you who got it wrong, do you see what you did wrong? Or are there any questions on those steps? We're good?
Yes, sir.
Okay. So here we go. I did not finish all of them. There's more for me to practice here, and we didn't get into solving linear equations. So what I'd like for you to do for homework is page 225. And just try and do as many as you can on page 225. All right. On page 225, do as many as you can. So our homework for tonight is, let me get back to that one. It was this, and it was also page 225. Do as many as you need to. So I want you to work out as many as you would make you feel comfortable, all right? And when we start class again on Thursday, I'll start with questions, and we'll get through we'll do linear equations. So it looks like our test is probably only gonna have on it fraction stuff, word problems with fractions, order of operations, and then some linear equations. I don't know how far we'll get with it, but that'll be all that will be on that test. So make sure that you're keeping up with the homework, and I will see you on Thursday. I'll hang out here if you have any questions.
Thank you. Have a nice day.
Have a good day. Yep, thank you.
Have a good day, sir.
You as well.